This question unloads a bunch of different ions on us and asks us to determine what neutral atom is isoelectronic with each of these. To answer this, I'd like to begin with the easiest one, which is iodide. Iodine by itself is element number 53 on the periodic table. When it attains one electron to get a -1 charge, it now feels, electronically speaking, like it has shifted one position to the right on the periodic table. So iodide, I-, is isoelectronic with xenon, element number 54. Lead is element number 82 on the periodic table. Every time an element loses an electron to gain a positive charge, it electronically feels as if it's shifting one position to the left on the periodic table. So lead 2+ feels as if it is element number 80, which is mercury. So I'll go ahead and write these down. By analogy, manganese losing 7 electrons feels as if it has been shifted, electronically speaking, 7 boxes to the left on the periodic table. Manganese happens to be element number 25 on the periodic table. You take away 7 electrons, it now feels like element number 18, which is argon. Zirconium is element number 40 on the periodic table. If I take away 4 electrons, it now feels like element number 36, electronically speaking. That element happens to be krypton. I wanted to end with this one, Gallium 3+, and the reason is because I frankly think that one is the most confusing and difficult of this lineup. Gallium is element number 31 on the periodic table. If you write out gallium's electron configuration, its condensed electron configuration, it has an electron configuration of argon, 4s2, 3d10, 4p1. Now gallium is going to lose these 3 electrons from its outermost shells, these 4 orbitals. So what that means is that gallium 3+ has an electron configuration of argon 3d10. When I tell you that gallium 3+ is isoelectronic with whatever element is element number 28, that happens to be nickel, you might be confused then. You might think, now wait a minute. Gallium 3+ doesn't have the same electron configuration as neutral nickel. It's got an electron configuration of argon 3d10. And that's absolutely true. Gallium 3+ doesn't have the same electron configuration as neutral nickel. It doesn't. However, that's not what the question is asking. It's asking what neutral element is isoelectronic with gallium 3+. That term, isoelectronic, really only means what element has the same number of electrons as gallium 3+, not the same electron configuration. Therefore, the correct answer to this question is element 28, which is nickel. In this question, we're asked to compare the ions fluoride, F-, and sodium cation, Na+. Both of those elements are isoelectronic. They have the same number of electrons as neutral neon. But the question doesn't ask that. The question asks us to compare size. How in the world do I determine which one is larger and which one is smaller? The answer comes down to the number of protons. If I have 2 atoms and they have the same number of electrons, as is the case here, then whichever atom has more protons in its nucleus is going to have a stronger positive charge in its core to suck those electrons in, thereby making the element smaller. The number of protons in each of these elements is of course equal to their atomic numbers. In the case of fluoride, that is 9. In the case of sodium, that is 11. Because sodium has more protons, 2 more protons to be precise, than fluoride, sodium cation is going to suck its electrons in more tightly, and therefore sodium cation will be the smaller of the 2 ions.